Hi guys, welcome again on my ACI tutorial, and we are going to start a new series on ACI Multi-pod. We already have covered ACI single pod in my previous videos. So today we will discuss that why multi-pod is required and what is the physical architecture of it and what is Cisco recommendation parameters to create it. So we will do each and everything on whiteboard so that you can understand step very clearly. Okay. So what is the need of ACI multipod? First question arises, right? So you might have seen in the legacy network, we have core network, or you can say the core layer. This is my core layer. This is my distribution layer. It is connected like that, crisscross. And here we have access layer. This is my distribution layer, and this is my access layer. This is old, or you can say legacy network architecture. Legacy network architecture. So what happens? Suppose you are moving towards the ACI. So in ACI, we know that we have leaf and spine architecture. Here is spine. Here is leaf. So as you know, all leaves are connecting to a spine. So if we compare a leaf with the old architecture, so we can say that this leaf is basically access layer and spine is basically equivalent to both core layer and distribution layer. So you can say it is a collapsed core kind of thing, right? So in previous legacy network, this is ACI network, ACI architecture. So in previous legacy network, you see that all my access layer are connecting to the distribution layer. An example, if we can take here, suppose this is a one campus, one building of the data center, building 1. This is my second building, building 2, building 2, and example, this is my building 3. So now you are noticing that my distribution layer components, or you can the switches, are directly connecting to the access to the core layer. Okay. So if we are going to expand network within the building, we are not going to increase the connectivity from the building to the core layer because it will remain same. Only we are adding here some access switches, like that. So suppose we are going to add one more piece here, let's say here. So we are going to add it like that, but we are not increasing any uplink from the distribution to the core layer until unless it is bandwidth constraint or something else, but normal it will remain like that. But if we are going to replicate the same architecture in ACI, so building wise we are having this layer only, because there is no concept of distribution. So in that case what will happen, suppose I have a building here, let's say I have one building here, this is building 1, this is building 2, and let's say I have another building here, building 3. So I am going to add connections like that. So as you are sensing, each leaf is connecting to the spine. So if we start increasing or number of leaves in the building, I have to stretch all the connections up to spine. So in that case it is not feasible for me to stretch cabling from one building up to spine every time when we are adding any. So what is the option in ACI for this solution? So number 1, so we can say limitation. If DC is spread in multiple campus, number 1. Number 2, suppose I want to put these leaf switches and numbers are going beyond 200 leaves. So what will happen? So there is a limitation of pod. Pod can have up to 200 leaves only. So this is my another limitation, why I need the separate pod. Suppose I need 300 switches, then I cannot put into a single pod because it has limitation. So I have to create another pod so that I can accommodate this requirement. This is another constraint, and that's why we are going for multi-pod. Okay, number 3, because data center is built from the redundancy perspective, because it is very critical if components within the data center gets failed. So many you can say tenants or so many applications which are being served by the data center are going to be impacted. So resiliency is main criteria here. Resiliency. So resiliency not on the physical level, on you can say logical level, right? So resiliency physical and logical. How we are going to achieve it? We are going to achieve it through the creating multiple pod, physical. Logical, if we are going to separate control plane of these ports separate. So in case if control plane gets fail of one port, it is not going to impact with the other one. Okay, so I am just going to present another slide here so that we can understand it. Okay, give me a second. Let me open it here. Okay. Here is my spine. Here is my leaf. Okay. This is my leaf and spine architecture of ACI. Generally we connect our epic controllers here. So this is my leaf, this is my spine. As we are aware that between the leaf and spine there are three protocols generally runs. One is called ISIS. ISIS protocol is basically to provide you infra connectivity. Infra connectivity means underlay connectivity. This is one. Number two is COOP. COOP is basically to update. Suppose here one endpoint is connected and its information basically will go to the spines, but it will go through the COOP database. I'll explain all these things in my upcoming lecture, or you can say upcoming video on the multi-pod, so I will explain each and everything in detail. Okay, and third is MPBGP. Suppose we have L3 out connected here, right? L3 out, it is called a WAN. In layman term you can say WAN. So whatever traffic, whatever routes we are getting here, it will go here and it will distribute here like that. Okay, or in other leaf. So these are the three protocols which run between the leaf and spine here. So if we are going to connect another pod, so these two as a control plane will remain separate. So each pod will have separate control plane. So in case if logically this get fail, it is not going to impact to other pods control plane. Okay, now we can move ahead and go on much detail on it. Okay, so I'm going to tell you what are the protocols generally runs in the in multi-pod. But prior to that, I'm going to tell you how this multi-pod is basically created. Here is my spine. In one pod I'm making first pod. This is my leaf. I will represent it via LF, and here are my spine. This is represented by SP. full mesh. Now all the discovery, all the registration of the leaf and the spine we already have discussed in my previous video regarding the single pod. So all is done and working fine here. So I am assuming that you know how single pod is built. Okay, so from this assumption onward I'm moving ahead. Okay, so what extra you will need? You will need, suppose you want to add multi-pod, means the 3 pod 4 pod in one data center, and you know that only 2 switches are sufficient to connect all. Suppose you have nearby buildings, those can be connected on these 2 spine switches, on the IPN switches, so you can do so. So these switches are basically 93 series switches, but not controlled by the epic. In the single pod we have epic here, like connected underneath of the leaf. So all these leaves and spines are controlled by the epic, but these 2 switches, upper one name IPN, interpod network, interpod network switches. So IPN switches are not controlled by the epic. So you can say these are kind of a legacy switches, as you are controlling through the CLI or through the API, but through the CLI, so directly you can go and log in and do the configuration, all these things, right? So now, so what connectivity pattern will be? Okay, so from the spine, generally from the redundancy perspective, we connect it both the switches, right, like that. Here I am creating another pod. Here I am drawing another pod. This is only physical connectivity I am making. In initial phase, you have to only create so you can represent by SP and you can represent it by LF. Now what we will do this, rather than putting all my epic cluster here in the single pod, I will put my one epic at least here. So if you are making 2 pod, so you can put 2 epic here and 1 epic here, because for cluster you need 3, so you can say epic 3 here and epic 1 and 2 here. So I am connecting it like that. Only physical connectivity is being done in this architecture. So first you build this network like that. Now we can say that this is a pod 1 and this is pod 2. Pod 1, pod 2. Only physical connectivity you have made. Okay. Now we will go on the next point. what are the requirements to create this apart from the physical connectivity? Okay, so number one, IPN requirement. IPN requirement. I will tell you each and everything in detail after some time. So here let me remove it first. Let me write it here. Pod 1. Okay. Number one. What is the requirement number one? To create interpod, there is a requirement of OSPF. What is that? From this spine to this IPN, we need OSPF. So we can say OSPF is required to make the reachability of the tap pools of this pod to this pod. Okay, so IPN are generally connected in this fashion. We are making one port channel here in between the IPN switches, switch 1, switch 2, and this port channel is basically providing the extra redundancy in case of the link goes down, so there should be connectivity here. So OSPF is running. So OSPF is running here. OSPF is running here as well, in between, let's say here. So between here as well, OSPF is running here as well. So first requirement is OSPF. We have to run OSPF. After that, we will run PIM bidirectional. PIM bidirectional. What is the meaning of that? Because if we are going from this leaf to another leaf here, and bump traffic is being crossed from one port to the another port, so we need multicast enabled. Okay, so when we need a multicast enable, so to make this enable, PIM protocol will run here. PIM routing protocol will run here, so that all the information related with the multicast group can be exchanged, and IGMP request from the spine is basically sent to the IPNs to make the registration here regarding the GPO. I will explain it, but this is second requirement. Now we are moving on the third requirement. Third requirement is the jumbo frame. Jumbo frame. Jumbo MTU. Okay, so MTU should be ideally 9150 so that VXLAN traffic can cross. When we generally enable VXLAN, so it becomes a jumbo frame. So to support the jumbo frame, we generally set this value 9150. It is Cisco recommended. Fourth one is routed interface. Routed sub interface. Routed sub interfaces. So between the spine and IPN, there should be routed sub interface. There should not be SVI here created, and VLAN 4 should run on this. So .1q is 4. Okay, .1q value will be 4 here. It is Cisco recommended. Cisco recommended. number 5th, QoS. So this communication should be prioritized because it is a kind of a control planes here, so that's why it is QoS, but it is optional. Number 6th, between these two pods, round trip time 50 millisecond should not be more than this. So 50 millisecond is round trip time. If your one pod is having more delay between seed pod, this is generally called the seed pod. Seed pod means initial pod, seed pod. So from the seed pod to the new pod, if this delay is more than that, you have to consider something else, because this is not going to work, or if it is going to work, it will misbehave. Okay, so these are some basic requirement. Those are needed to run our our interpod. So in this video I will keep up to here, and in my next video I will tell you what subnet you should consider and how many those subnets are, and those subnets will be assigned to the tab, and what are the different kind of tab, and how this will be assigned here on the IPN, how it will be assigned in the spine. All those information I will give you, and after that after that video I will tell you how packet flows works. Okay, so I think it will be clear to you how we are progressing to design the multi-pod, what are the limitation because of that we are choosing it. So I try my level best to make you understand. If you have any question or anything, you please mention below in your comment, and I will try to explain you further. Thank you very much for watching this video.